Good morning. Welcome back to the Sustainable Manufacturing course. This is an applied approach course in which we are trying to obtain sustainability through green manufacturing systems. We are trying to learn how to do that. Now, in this session, I would cover sustainability framework. Now, I'll start with my first topic here, that is triple bottom line. What is this term, triple bottom line? So, I will explain this with the help of Venn diagrams. Now, we have three players in sustainability. Number one is economic, and second we have social, and third one is environment. Now, triple bottom line is essentially an accounting framework with these three parts, that is social, environmental and economic. This is actually, this takes into concern the financial aspects, and this takes into consideration the this one social, the people, right. It is also known as 3BL, triple bottom line, 3BL, or PPP. We have people, planet and profit. So, we have 3 P's here. So, this is the portion when all these three work together, come together into one point. This is the sustainability. So, this intersection becomes socio-economic considerations, and this one becomes eco efficiency. And this one becomes socio environmental. Now, the economic player here consider about the capital efficiency, risk management, margin improvement, growth enhancement, then total shareholder return, and maybe innovations, technology, all these things. This is a manufacturing. So, this is all related to the economic concerns, that is financial concerns, that is the growth of the company is considered here, growth of the company, or maybe the growth of the nation, that is considered here. Then social aspects include the diversity, human rights, all then indigenous communities, labor relations, all that. And in environmental, we have clean air, water and land, then zero waste, then also I could put here biodiversity. So, this is a very simple kind of and very popular sustainability framework. Now, when I have these three circles here, I would like to put some more detail here. This one, this player is concerned about, it is bothered about creating value, and obtaining returns. And second player, that is our social player, He is concerned about societal commitments which involve the quality of service, then availability of jobs, availability of social services, and this environmental player is more focused towards the commitment in safeguarding the environment. So, when economic and social combine, they are committed towards development of societies in which we live. Development of societies. Taking into consideration the profit levels of the companies that are providing products to the society, and those who are creating the facilities for the society like infrastructure and other things. And this one, economic and environmental, they are more committed towards efficiency increase with waste reduction. Efficiency increase implies less energy. And this one, when social and environmental aspects come together, they are more committed towards health, safety, and maybe personal and professional development. So, this is one of the framework that is known as triple bottom line. Like in traditional business accounting and common usage, the bottom line refers to the profit or loss. That is why this TBL, this bottom line refers to the profit and loss. That is why bottom line term has come up here, which is this one. Bottom line is like the profit and loss is usually recorded at the very bottom or like on the statement of the revenue. Like on the statement of revenue, we have, it is a statement like this, and at the end we have what is profit or loss. All accounting is put in here. So, that is why this bottom line is there. Also, these could also be said as the pillars to sustainability. If I have my sustainability here, so this is economic, social and environmental aspects. These are essential pillars or very necessary pillars that are required. Without even each one of these, the sustainability would not stand. This sustainability would fall down without even one of these. So, three of these needs to be considered altogether. So, next is sustainability versus green manufacturing. Sustainable and green are being used interchangeably. Sustainable, people said this product is sustainable or it is green product. But what specifically is the difference here? So, sustainability is a broad term. This is sustainability, of which green manufacturing is a subset. So, green manufacturing works in the manufacturing sector of sustainability. Sustainability is to consume the resources in a way that it does not affect the future generation as well. That is, future generations should also be able to produce or use the resources in the same way we are doing it today. That is sustainability. And when the products those are being manufactured for the sustainability approach. Those products are produced by green manufacturing technologies. Green manufacturing is then producing the products that have less waste and consume less energy. So this is green manufacturing is consuming less energy and reducing waste. I am talking about my product here that is being used. Sustainability involves all other things like eco harvesting, agriculture, then plantation, everything is part of sustainability. So next I will talk about manufacturing system. For green manufacturing is done in a manufacturing system. Now, what is a manufacturing system? This is being discussed in the previous lectures by Dr. Deepu Philip as well. So, in manufacturing system we have a facility that can be subdivided into process chains, and these process chains consist of our unit manufacturing processes. If you could recall, this is my facility or a factory which has various sections, and we have process chains here, and this one unit is my unit manufacturing process. So, at each level, facility, process chain and unit manufacturing, what are the considerations? So, what we actually doing, we are trying to narrow down our scope here. So, we started from sustainability, then we are coming to green manufacturing. For green manufacturing we are defining the elements. The elements, first element is facility, then we will go down to process chain, and then we will go down to unit manufacturing process. So, this has multiple unit manufacturing processes here, and this has multiple process chains here. Process chains. If I say green manufacturing, if I say manufacturing here, this is if I say I can even have industrial park here. Industrial park has number of factories here, factory 1, factory 2, right. So, at facility level, what is my point of consideration here with respect to green? So, it is the plant design. Here in this plant we need to have building design, that is green, building, then layout of the machines, then we have in the building we have air conditioning, maybe HVAC, and ventilation, lighting. So, all these participants here consume energy. So, there are soft tools that are available for example, BLCC, building life cycle costing. There are special tools that are available for designing of building for less consumption of air conditioning, less consumption of energy in overall, for air conditioning, ventilation, lighting. Everything is designed in a way that building is kind of a green building in that case. In layout design, we need to consider minimum mobility, that is minimum material movement, material handling should be minimum. Then we have worker pathway to move, then span between machines, span between machines, that how far machine needs to be placed. So this is facility level. Just a quick glance over that. Okay, I would like to share one more thing here, the temporal effect in the manufacturing. So we have temporal decision scale here, and this is manufacturing analysis. Now we can divide it into certain sections. So we have manufacturing enterprise, that is facility here. Then I have process chain. Process chain is also known as flow line, right? Then I have my manufacturing machine, and in the machine the sub components, and then further I would say at micro level tool chip interface. So this is time. I have time here, milliseconds, seconds, hours, and days. So if I try to widen my scope here, I could even have facility has some management here, and we have full supply chain here, right? So this is, at this point it is known as process control, and this planning, actually the plannings comes into play at this point. It is micro planning. So process control is controlling the tool chip interface, like the energy that is being consumed while machining, the tool that is being used, how the tool movement is there, the movement of the tool should be minimum, and the cutting fluid, kind of cutting fluid we are using, the cutting fluid ingredients, all those things. In tool chip interface, what is the energy, what is specific energy coming out, that is considered here. That is even lower than micro planning, that is process planning here, process control here. So when it comes to process chain here and machine equipment, it is macro planning here. And macro planning takes from a few seconds to hours to do. Then at facility level planning, it might take a day, from few hours to a day, right? So I would even put weeks here. So this is known as production planning. Production planning include everything like planning, scheduling, then implementing, routing, etc. in between. So after that we have here is supply chain. Supply chain, it is supply chain management. So Dr. Deepafuli would cover green supply chain topic in the forthcoming weeks. So what is green supply chain? All the purchasing and transit of the goods have to be done with lesser carbon footprint, that is green supply chain. How would do that, and what are the elements of that? Information on that would be given by Dr. Deepafuli in the forthcoming sessions. So this is temporal effect in our manufacturing concern. So this is taken from a book by Dr. Dornfeld, and this illustration was brought up by Vijay Raghavan. So, this was published in 2010. So, next I have is in my facility I have my process chain. The resource consumption in process chain is to be considered. What is resource consumption here? The things which we have been discussing since the beginning of this course, that is energy, water, and because I am talking about manufacturing concern here, I will put here consumables, right. Then we have resource consumption and waste. This waste is carbon dioxide, right, then solid, liquid and air waste, then energy conservation. I am putting it in energy conservation in this waste category only. So, these things needs to be controlled in my process chain. So, process chain is nothing, this is one process chain. We have process 1, process 2, process 3 and process 4, and material is flowing in, and this transport of material, this also consumes energy. This is known as material handling, right. So, this also consumes energy. So, this also needs to be considered here. So, next I have is my process level, rather I would like to say here unit process level. So, unit process is my one process. So, it is one machine, maybe it is, say it is a lathe. So, the lathe is a machine that produce cylindrical jobs, or maybe grinding machine or milling machine, right. So, this is one machine here. So, in this case we are working here now one machine at this point, machine. So, this is macro planning. Even we would work here tool chip interface. So, what are the things that needs to be controlled here? What are the factors that need to be controlled? It is the energy. Here we have, so it is from this point the green manufacturing process starts. It is actually, we say energy or specific energy, energy per unit volume that is removed, specific energy per unit metal removal rate or per unit depth of cut. This is the point from where green manufacturing starts, and from here we can produce unit green manufacturing process, or the process that consumes less energy or is green or produces less waste, and this can be taken forward to the process chain level, like unit processing process can be combined together. Then we can see what is the energy level, total energy consumption in that case. Then these process chains which are now green process chains, that can be taken forward to my facility level to convert whole facility into a green facility, right. So, in this case I would say I can have plots like this: specific energy, right, and this is, on this case I have, this is my actually output parameter, and I have input parameter here, that can be metal removal rate or speed of my spindle tool or feed of cutting or maybe depth of cut. So, this plot say it is like this, some kind of plot would come. So, this is specific energy. So, this can be compared with the quality parameters. For in quality parameter I could even say tool wear, right, or it can be surface finish, right, and here also we can have the same kind of input parameters. Right, this tool wear or this, if it is tool wear has to be minimum. Tool wear needs to be minimized. For example, with MRR, sorry, it would be always like this. With more MRR, tool wear would be high. So, this is tool wear. Surface finish can have transit behavior. For example, surface finish can be like this, something like this. So, this is my energy parameter and my quality parameter. These needs to be combined together. So, we can even have multiple parameters here. I have only considered 2 parameters here, but other parameters may be specific energy, cutting fluid consumption, waste or that is produced in the machining, then solid waste, chips that are produced, then water borne waste here, then tool in quality parameter it could have surface integrity, then tool is one of the criteria very important here. So, what we do here in the forthcoming sessions, we will do labs demonstration and show you how do we conduct experiments on this unit manufacturing process. Right, we will conduct live experiments, then we will optimize with respect to green manufacturing. So, there are certain other steps to finally obtain green facility. I will let you know when we do this green facility. So, next I have an illustration here that is trying to explain the different techniques that can be used to have green grinding. So, this is a grinding wheel here, and this is my workpiece. So, grinding is typically a finishing process after doing any kind of machining, for example, maybe turning or milling. Grinding is the final process to obtain the final shape. The grinding allowance is always kept during rough machining. Maybe in milling, some grinding allowance is kept, and grinding produces finished surfaces. Like the type of surface finish required, the wheel type of wheel is selected in that way, and there are specific wheels, specific wheel abrasives that can machine the specific workpieces here. Hard wheels, for example, CBN wheels can be used to machine titanium workpieces, and aluminum oxide abrasive can be used to machine mild steel or some other kind of soft materials. So, this is grinding wheel that is machining my workpiece. Generally what happens, we do the grinding, we do a few runs of grinding, and then we dress the wheel with help of a diamond dresser. Diamond dresser is nothing, it is just kind of this pen, and the tip has a diamond over here. So, what we do, the wheel is rotating, this wheel is rotating, and this diamond dresser would dress the wheel. Obviously, the hard material would cut the softer material. In this case, this grinding wheel is hard and my workpiece is a soft material. So, it is cutting this one. So, in this case, this dressing is being done by my wheel dresser, which is a diamond tipped wheel dresser. So, what this illustration is explaining here, it is doing continuous dressing here. Like machine has to be stopped. The overall actual production, that is the production time, that has to be stopped for grinding in a regular practice. That is, machine has to be stopped here, the workpiece has to be taken away, and then we do this dressing and we prepare the wheel for further sessions, and then we again bring up the workpiece together. So, in this case time is consumed. So, to minimize this wastage of time, this continuous dressing is one of the criteria, but these dressers are not very commonly used. So, also we have solid lubricants here like graphite or molybdenum disulfide that helps to produce better surface finish here, and these solid lubricants would even keep the wheel life better. Then there is a process called as minimum quantity lubrication. We will come to this. So, in regular practice what we have a cutting fluid. In the normal practice we have a cutting fluid that is supplied in a flow rate of maybe 5 to maybe I would say 3 to 8 liters per minute. So, in minimum quantity lubrication what we do, a mist or aerosols are produced with help of some arrangements, with help of some setup, some ready-made nozzle can be procured for that, or some setup can be made to produce aerosols, to produce the mist. Flow rate in MQL, the flow rate comes down to even 10 milliliters per second. Please note here carefully, this is liter per minute and this is milliliter per second. So, the difference might be 10 raised to power 5 times lesser fluid is used. So, what are benefits of this? One thing is the fluid is saved, other benefits we will discuss in the further sessions. So, this is one of the technique here, right. Then we have cooled air or liquid nitrogen. Heat is produced at this tool, this is my tool and work interface. Heat, very high heat is produced. So, this liquid nitrogen and cooled air can help us to control this deterioration of my workpiece surface here. So, also there is a process known as cryogenic machining. In that case also it is done at very low temperature. Then we have kind of nozzles here, shoe nozzle, jet nozzles, those nozzles are used to supply this fluid here, right. Then also the grinding specification, he says grinding specification like bond, grain size, wheel topography. Actually grinding wheel is having the cutting ingredients in that, and also to bind that we have bonding material. So, it is abrasives and the bond all are all together make a grinding wheel, solid grinding wheel here. So, this bond can be face centered, body centered, the similar kind of bond we have in our crystal structures, right. So, the type of bond also depends. Then wheel topography also could affect my quality here. They also have put here suction system. Suction system would suck my chips that is produced. In this case the chips are very small. I would say the kind of dust is produced, and that dust includes the abrasives, the cut abrasives, the grits, abrasive grits, and my workpiece material that is therein. So, that if that would enter into this tool work interface, that can also contribute to poor surface finish. So, the suction system would help to suck these dust that is produced here, so that dust does not enter in my tool work interface here. So, with this I would like to conclude this session, and in the forthcoming sessions I would discuss these kind of techniques: minimum quantity lubrication, cryogenic machining, and this is actually minimum quantity lubrication. There is also one method that is known as dry machining, that is do not use cutting fluid, they suggest, right, no cutting fluid at all. So, this is 3 to 8 liters per minute, this is 10 milliliter per second. In this it is 0. But what happens to my specific energy, what happens to my surface finish, what happens to my tool wear in this case? In this case, if it is a dry machine, the temperature would rise because cutting fluids also helps to keep the temperature in control while machining. So what are implications in that? That we'll discuss in the forthcoming sessions. So for today, thank you.